So now that we have our servo circuit all hooked up, and we should have a potentiometer hooked up as well, we will go to File, Examples, Servo, Knob, like so. And just a couple of brief explanations about new things we're seeing in the code. When you see a hash include like this is including a library, and a library is a set of functions which allows us to more easily access different kinds of hardware that we might hook up to the Arduino. And you'll see here what we've done is actually told the Arduino code to recognize a servo, and we've named it myServo. And for example, if we wanted to have another servo in this code, we could say something like myServo2, etc. So really it's you can think of it in the same way as a variable. It's technically not a variable. It's technically an object. It's created an instance of the servo class, but we can just think of it as in the same way as we do a variable. We're saying, okay, Arduino, I have a servo and I want it to be named myServo. And then inside of the setup code, we want to tell the Arduino that that servo is connected to pin 9 of the Arduino. So we've used this .attach method. And you'll see this when you start working with libraries, this way of telling an instantiated object, in this case the servo, to perform a particular command using this dot notation. So here we're saying, okay, attach to pin 9. If we wanted to attach the servo to pin 10, if we wanted it to be connected to pin 10, we would do something like that. So inside the loop, we see things that are familiar. We have this int val. It's actually not initialized. It's probably better practice to initialize it, but it shouldn't matter. And so we're saying, okay, val is going to contain this analog read, which we've looked at. And then also we have this map function. And this map function is a really useful function. And it takes a little bit of time to understand. But what's happening here is we have a value, which again is the output of this analog read function. We've plugged it in here. We're saying, okay, value, now I want you to equal the result of this map function, right? So I want to put inside of that first, it puts inside of val the analog read right here. And then directly after that, it puts inside of the val variable the output of this map function. So what we say is the map function is returning a particular value that we are then storing briefly and temporarily in the val variable. And so we have this map here, and it's saying, okay, take the output of val, take this constantly changing variable of val, and change it from a number between 0 and 1023. And if you remember, there is a possible range of values in the Arduino analog input between 0 and 1023. And then transform that range of values into a number between 0 and 180 degrees. If you want to know more about this map function, remember that we can right-click or control-click and find and reference here. But the reason why we want to change this into a number between 0 and 180 is because the servo wants to know a number between 0 and 180 degrees. It can turn in a half circle. So that is the angle. That is a number in degrees. And this is why the map function is so useful, because quite often when we're working with Arduino, we want to map a somewhat useless number like 0 and 1023, or perhaps I should just say an arbitrary number. And then we map that arbitrary number into a range of values which actually pertains to the task we want to accomplish. In this case, we want to position a servo between 0 and 180 degrees. And here we're saying, okay, well, my servo, we're using this .right function, which actually tells the servo to be at a particular position. And there's a small delay just to stabilize the system. So this isn't constantly updating. There's a slight delay between the servo going to its new position and the value of the analog read being updated. And what should be happening is as you twist your potentiometer, you should see the servo turning between around 0 and 180 degrees. You should see a demonstration of this in the video pertaining to the particular circuit. And lest we forget, we have to actually upload this again to the board. Don't forget to make sure that your port is correct and upload it, and then we're done. And so now you should be able to twist that potentiometer and move that servo around again between 0 and 180 degrees. If it's not working, check your circuit. That's as long as it's uploaded, you will know that the problem is not on the software side, it's not on the programming side, it's on the physical side.